Good afternoon again. Let's get started. So, like I said, this session is about the latest and greatest in the industry right now. And to present a full stack picture, so to speak, we have with us today folks from almost the full, all parts of the value chain. So to start with, let's start at the top of the value chain, so to speak. The end user side, we have all the way from BC, Roy Hart. Roy, if you could, right after that, if you think about moving up the value chain to represent OEMs and chip makers, I have Nalli from AMD right here. Next, we go to the data center so-called facilities side. How do you stick a bunch of OEM like servers into a room? And to tell us about that, we have Herb all the way. He flew here from New Jersey. And last, and definitely not the least, to present the end-to-end picture, data center as a service, all the way over from France, we have Benoît. Hi, Benoît.
Hi.
So I wanted to introduce everybody in more detail, but then I figured, you know what, I'm not even qualified. So I'm gonna ask our panelists to do a little bit of a very brief introduction. So if we could start with Roy, if you want to go first.
Oh, thank you so much. I'm Roy Hart, the Chief Information Officer at the British Columbia Institute of Technology. I've spent my entire career in enterprise IT and the last 12 years as a CIO. And, that's who I am. Yeah, did you want me to go into what's interesting right now, Suvoji, or after?
Yes, absolutely. So another thing I was going to say is while you're introducing yourself, if you could talk a little bit in 2 sentences, what's like the most fascinating thing that you're doing right now?
Yeah, so at BCIT, I think we're a big polytechnic institution. I think the most interesting thing that I have going on at the moment is something that we call Smart Campus, which really at the heart of it is about bringing IoT to life for our faculty and students. And we believe that it's going to introduce new ways to teach and learn. And I think throughout this session this morning, we'll end up touching on some of the factors that relate to that.
All righty, and next let's go to Benoît, because you're right next to Roy over there on our screen here. Benoît, if you want to talk a little bit about yourself and what's the most fascinating thing going on in your world right now.
So I'm Benoît. I'm working with OVHcloud for 1.5 years. I have mostly a financial background, so I won't be so qualified as you are guys about IT. I'm working with our founder, what we call strategic deals, meaning extending significantly your footprint with new geographies, sectors, everything linked with big CapEx investment or partnerships. And I think we will speak later about this as a service, but I think the most exciting thing about OVHcloud at the moment is this huge catalog of services, more than 80 services we are building up, and we should achieve around 2022. It's very consistent. It's very much embedded with OVHcloud culture of transparency, reversibility, open source. And I really ask you if you can to have a look to it, because I think it's a very interesting thing to happen at the moment.
Well, thank you. Yes, indeed. We're going to talk a lot about that. We did a prep session with each one of the speakers, and it was like probably the most exciting half hour I spent this year learning about the latest greatest. So next, let's go to Marco. Marco, if you want to introduce yourself, talk about the most fascinating things happening.
Great to be here. Pleasure to be in front of you today. And I manage the enterprise business for Canada. So I manage all of our data center, CPU products, as well as our desktop and client business. And now I'm moving more and more into cloud infrastructure. But yeah, one of the impressive things that I've seen this year is the amount of, obviously, the amount of supply that we've had to move over the last 1.5 years. And what's equally as impressive is, all the IT administrators and data center administrators on how fast they're able to move some of that infrastructure in place and being able to basically keep everybody up and running over these last 2 years. So I think that was a quick and give them a round of applause, but I mean, it's been impressive. We've moved a tremendous amount of supply. AMD has gained significant market share globally, and I could speak for Canada. We've basically been able to triple our business without getting to specifics, but the demand continues to increase. So I think that's an important feat and something that's keeping me busy is moving supply to our customers.
Thank you, Marco. And last, but definitely not the least, Herb, I'm a big fan of your stuff. Like if any of you have seen my lab upstairs, it's entirely Rittal. So if you could talk a little bit about yourself, but then also like all the new stuff that you're up to.
So again, good day to everyone. Thank you for joining us. And as Marco said, it's nice to get any place that's not New Jersey. It's a New Jersey thing. So with Rittal, it does hit areas. It is Rittal North America. I'm their solutions consultant. My job is to work with really everybody in the room, everybody in our audience, to provide infrastructure solutions at the enclosure, climate control, power distribution level as Marco's equipment is deployed further and further and further out in the field, and more and more and more of them in anywhere from the cloud to what's most exciting for us is the edge. So that's something that Rittal has been really focusing on this past year and a half, especially in the era of our pandemic, and all things at the edge. We have been defining where the edge is, what the edge is from both physical perspective, as well as we will branch out into edge computing and so on. I can tell you firsthand, coming up to Canada, I spend more time on the edge with all of my documentation and my testing and my emails to get up here than I will be here in Canada. So for us, that's what's exciting is the edge and all of the power it is bringing to us.
Well, Canada is kind of the edge, right? We're the final frontier. But well, thank you for flying all the way here. So you got on a plane to be here. What's that like?
There were no crazy people, no fights, no duct tape, no tie wraps. So it was a good flight, but it's interesting in just watching the interaction with people and the regulations, and people are accepting it. But at the same time, we're all using our technology. We're all everything that I did was done online. My reservations, my contacts with our Rittal Canada people up here, preparing for the conference, our Zoom calls, our meetings. So all of us are living in this new world, in this pandemic world, and taking advantage of everything from the cloud, through the IoT, through the application, through the devices that I need to make this happen. That's the world we are in today, and it was an interesting journey.
It is a strange thought. So my first question here, Roy, when we were talking about this in the prep session, we spoke quite a bit about like moving your services as much as possible from an on-premise location to SaaS services that are available, etc. Could you educate us a little bit more on why you are going this route, how those decisions were made?
Well, the first thing that I'll say is really there's many barriers, including maturity as software as a service for specific verticals. I think that's something that is really slowing down that journey quite a bit. But the reasons why, you can increase automation and ideally implement loosely coupled integration opportunities. So it'll allow you to move to a better product faster, easier, cheaper, without having to rebuild your entire environment. Almost always, in my experience, it's a higher service standard than what we can provide in an on-prem solution. Like I've been in this field a long time, and there's always something that's an issue with our data center environment and how it's built and all of that, always something to deal with. It's fundamentally faster time to value with the software as a service solutions. I don't know what to say other than that. It is a lot faster time to value than doing anything on-prem could ever be. From the past 10 years or so, the innovation cycle on most software as a service is way higher than anything on-prem. In fact, it's increasingly harder to find on-prem solutions to meet your business needs. Almost all of them have moved for a variety of reasons. some of the financial, to have recurring revenue on a subscription basis, or whatever the case might be. But the investment is all in software as a service. It's not in the on-prem stuff so much anymore. And of course, there's the organizational attention span, and reduce the footprint, reduce the capital costs associated with the on-prem data center, and allow you to shift those scarce resources to things that are much, much closer to delivering business value every day than minding, the back end of systems that most people never ask about. And that's kind of why it is.
Thank you. Good kind of a follow-up question, which I'd pitch to Benoît here. Benoît, I've been a big fan of OVH ever since I had less gray hair, or like no gray hair. Building your own servers, liquid cooling, you do compute the way it should be. But lately, you've been moving more and more closer towards being like a infrastructure as a service, to platform as a service, to almost act software as a service. Yet at the same time, you have this new DC as a service product. Can you walk us through a little bit about this whole new concept of a turnkey data center as a service that almost competes with software as a service in a way, right? You provide something on-prem. How did that product come about? What was the core problem that you were trying to solve?
So just to define very shortly, DC as a service is an extension of all the cloud's operations we are managing for ourselves. So we have something like 33 data centers over the world. So we extend those capacities to the customer or the partner premises. So we make it available, I would say, on a privatized way. Okay. So it means that all the technologies we're actually managing for ourselves are available with these products. I speak about OpenStack, I speak about VMware, Bare Metal, and that they are all available in this service on the private mode. Okay. So this also implies that you have full access to this catalog of 80 services, as I was mentioning before, also on the private mode. I think the beauty and the value of it is coming from the fact that you are in some ways sharing with us or benefiting from the hyperscalers effect, both economically, because it's a quite competitive option and a very competitive alternative to a one-premise solution for most of the big corporates, but also from a technical standpoint, because you are benefiting from the consistent and significant and comprehensive software and hardware refresh we are doing also for own customers on own data centers. So you have, I would say, a technical and economical hyperscale effect in this. We're doing this for 1,000 servers to 50,000. I mean, we don't have a limit, upper limit. We have a lower limit, but not a upper limit. And I think the beauty of it is you get rid of all the technical work, the human legacy issues, the software and hardware refresh you would have to do for yourself in a very competitive environment. So I would say it's some kind of the best of the two worlds, if I can say so, if I can conclude on that.
Just as a segue to that, and I'll move on to Herb here, just like, you're bringing the benefits of hyperscale to on-prem, including what I love is the almost like automated, like fire and forget technology refresh cycle. Herb's been busy doing the same thing, but from a different angle altogether. So his focus has been more on powering the edge, a slightly different business problem than yours. But Herb, if you want to walk us through, like, what led to that and what are you up to?
Right. So the key is that from OVH at the cloud through a large end user. So we hear the terms hyperscale, we hear mega data centers and so on, but we need to bring that to a term that I like to use is hyper local for at the edge. We hear there are so many different types of edges. What we want to do is define where the edge is, what the edge does, what compute process, which Marco will talk about in just a moment, will be used at that edge but critically from the hyper local to the hyperscale. So we're scaling down. We're going the other direction, but we have to make sure that we provide all of the same level of support, security, both from a physical and a cyber. Now at the infrastructure level, which is where Rittal operates, not much I can do about cybersecurity except to make sure that your enclosure, which is what we do, the cabinets, you can close the door, you can lock it, you can at least keep me out with my little USB stick and all those nasty little viruses from that physical implementation. So what we're looking at is the ability to take everything that we expect, but bring it down to that edge level. It's something that's been around for many, many years, but as we did with the cloud, Benoît can talk to this, all of a sudden 10 years ago, the cloud, everybody had to be on the cloud. We had always been on the cloud. It wasn't something new, but we gave it a name, we gave it a service, and we turned it into something. It wasn't magic. We've been at the edge as well. But again, as we look at, so I talk about the hyperscale, I talk about the hyperlocal, and then I also talk about the mega trends that we are dealing with. Our first one is the one we're dealing with today, COVID-19, all the masks, all the vaccines, all the travel information I had to put into. I had to get my COVID test and so on. So we have a mega trend that the hyperscale supports, that the hyperlocal will help to make it better and mesh back to the cloud, whether on-prem, wherever we're going. That is the direction that we're going in.
Yep, that's a very good summary. Thank you, Herb. All right, Marco, I've been saving you for the last in this round because you bring the most important ingredient in computing infrastructure, the compute. I've been an HPC guy most of my life, and you can't be an HPC guy if you don't know your AMD chips. We've been talking about to put it in Herb's words, we've been talking about the hyper scalers and the hyper local. From a chip standpoint, and also extending that to from a server OEM standpoint, how do you differentiate your value props to the core and the edge, or the hyperscale, hyperlocal?
Yeah, that's a great question. I mean, if we look at where the workloads have taken us, we've definitely entered the era of high performance compute. We've taken technology to a whole new level. If we look at the last 5 years, in terms of where we've taken technology with the higher core counts and the higher frequencies, and really focusing on that side. So, to your point, Herb, when we talk about edge computing with 5G, that's definitely a key ingredient in terms of where we're managing localized workloads. But AMD's taken the stance that we're focusing on both sides of the fence. We're dealing with companies that have been physically challenged over the last year and a half in terms of moving equipment and moving product into the data center. Where we focus is, and we've recognized that the cloud has become more of a relevant discussion at this point. We're definitely seeing more and more conversations around cloud. So AMD's taking the approach is that we're working with all the big mega data center partners, such as OVH, and we work with our partners such as Equinix, and then the traditional AWS, GCPs of the world. So it's taken up a lot of our time in terms of working with all these hyperscalers. But we're not dismissing that there's still a market for on-prem. As much as people want to move into the cloud, it's a big lift. There's a lot of applications, a lot of DevOps that need to take place. So we're really focusing on working with our on-prem partners, but we're also taking the stance that we're focusing on the MDCs. And so as we continue that build that business, we're offering customers of choice. So there's now a wide variety of choice, whereas when you would go on-prem, there would be a traditional RFP or an evaluation and benchmark, but less so on the cloud space, as people were signing up to various instances, and then you just sign up and you pay the bill at the end of the month, and you have that sticker shock, and it's like you would just kind of pay the bill. But what AMD is doing now is we're actually offering choice. And so when we look at various workloads, including high performance compute, we're putting those choices in front of our customers now. So if there is an instance that's in market that you've been traditionally using one of our competitors, you now have the ability to at least benchmark against an AMD instance, where we can show significant performance improvements, as well as cost savings. And again, working with companies like OVH is that we're able to increase the rack density, giving you higher compute capabilities within those racks. And so again, there's a high performance compute conference several weeks back in Ottawa, and this was an area that really came up as the flexibility in terms of increasing on-prem data centers. There was a lot of discussion around cloud, and when you talk about researchers working on especially COVID type research, offloading that data onto the cloud, security starts becoming a bigger message as well. So security is something that we definitely tackle as one of our key pillars. So these are all areas that are all open discussion. And to summarize, we really need to we don't want to kind of over-index on the cloud, but we definitely need to work on both sides of that fence.
Thank you, Marco. Really well put. Just a quick follow-up on that. We were talking about the current 7 nanometers, and then you're moving on to 5 nanometers. What's the main driver for this? Would this be the hyperscalers, or would this be the edge side of things?
Yeah, I'd say it's a combination of both. I mean, since the inception of smartphones in 2006, 2007, that computing capability has really transferred into the palm of a person's hand. And I mean, there's not been a better time when we consider about everyone being, kicked back to home and working from home. So that edge becomes more and more relevant. Higher speed internet, reliability, and Zoom Teams calls that. We need to make sure that we're almost bringing that data center compute technology to our laptops. So an area that's driving that is again, if we look at the technology curve in the last 10 years, it's been fairly moderate. We have stats that demonstrate this. But if we look at where AMD has with the introduction of EPYC, which is our first 14 nanometer design, and then into our current, our next generation Genoa, which will be a 5 nanometer design, is that we're putting a tremendous amount of technology into a small die. So something that was 4-socketed 5-6 years ago, we can do in a single socket now. So we're driving to 96 cores to 128 cores on a single die. So we're putting a tremendous amount of density onto a smaller rack. So we're able to shrink your rack space, reduce your real estate, and at the same time as the big sustainability message in terms of trying to save you power. So we have the highest core performance per core versus power. And so the demand, a tremendous amount of demand on the end customers, and high performance compute is what's driving the high performance. And we're here to change the game, right? Is what we've done the last couple years.
Yeah, it's crazy how you're able to do it. All right, so thank you for that. So next we'll switch gears for a little bit. So this would be round 2, and since we're getting close to Christmas, this is when you kind of reflect on what you've been up to for a bit. So I call this round the ghost of data centers past, in a way, but more to explore the history of how did we get to our contemporary state. And my first question, this one goes out to Benoît. I've been stalking literally OVH for decades now, but if you could walk us through, in the prep session, you told me the beautiful story of how OVH was born, how it became a fully vertically integrated company, and probably the only one, to my knowledge, in the world that does that. Could you walk us through the origin story of OVH a little bit for the audience?
Yes, of course. So the story of OVH started in 1999. The Klaba family, because at the beginning it was very much a family business with father, mother, and 2 sons in the company. They were just coming back to France from Poland, so they were on the worst side of Europe, I would say, for some period, and very keen to come back to freedom. And the amazing thing about Octave is he wasn't even speaking French when he arrived at 16 years old in France. And then it started in 99, he was 23, 24, something like that, his business. We are today, I think, operating 33 or 34 data centers, 500,000 servers, something like that. We have manufactured 1 million of them. So we are one of the key players, I would say, in the European market, amongst the 10 first in the world. It's amazing. it's still a family business in the way it's managed, even if we went through a very successful introduction IPO in October, but still. What is very nice about the story is coming from this Eastern way of thinking, there is a very strong culture of frugality within the company. It was very much driven at the beginning by the fact that not recurring so much to banks, the cash efficiency was very important. So all is built around being very frugal and efficient in the use of the equipment, the reuse of the equipment, and the reuse of the equipment. And I'm speaking about the buildings, because we are doing a lot of brownfield, building, refurbishing an existing data center, but also the fact that our servers, which are very minimalist, less is more. It's really less is more. We reuse it 3 times, so we have 3 life cycles on the servers. What I wanted to say is this frugality leads to some sustainability, because sustainability is very much about frugality, and this is a very important thing is in the story. I think this is what you wanted me to emphasize, I think. Yes.
Absolutely, absolutely. I think it's a fascinating story, you know, where you started and how it evolved, and it kind of tells the story of you evolving there into like a fully integrated cloud like platform,
Yeah.
provider, then into
Yes. Okay.
infrastructure as a service, then platform, then the data center.
Absolutely. I have some business school background myself, and the Clava have done exactly the contrary what you be normally told to do, which is they have been successfully vertically integrating everything around them and diversifying and controlling the value chain from the beginning till the end. And this is not the normal thing to do. They have repatriated the manufacturing in France when most of the industry was leaving Europe and France especially. So they have done pretty much the contrary of everybody else, and it was a success. So get rid of business schools.
Yep, it's contrary to what they teach you in business school. You're trying to swim against the tide. People try to, dissuade you or like dislike you, or even get jealous in some way. So when you have like a little bit of an oops, like when you had that fire, I bet there were people who were around who were saying, "I told you so. Don't go vertical."
Yeah, actually, but also with the COVID, and we are facing at the moment some issues with components and so on. It's a very strong model. And the thing is, we see more and more industry coming back to Europe. So in some ways, it was quite visionary, I have to say. It seems very old-fashioned, but it's turned to be visionary at the end. So.
Yep. No, the model you have has been described by researchers and makes perfect sense in an academic context, but not in the context of business models sometimes.
Absolutely.
The fact that you've been able to run it so successfully for 20 years, more than 20 years now, and still evolving, that fascinates me. Next, let's go to Herb. So Herb, we've been having the same conversation, and you started with, Rittal makes big metal boxes. Yet what you sell is not a big metal box. It's way more sophisticated than that. So would you care to walk us through like the evolution of the Rittal system from being big metal boxes to being what it is now?
It really parallels the evolution of the industry as we see it today. So Rittal is a global manufacturer of enclosure solutions. Sounds very grandiose, but we make boxes. We make metal boxes. But we learned that in order to support the basic product, that we also had to have the power, the cooling, the security, the monitoring capabilities, and so on. And we have worked closely with OEMs. We have worked closely with data center providers. We have certainly worked closely with the end user community. And as they have evolved, as they have matured, and critically as they have adapted, as I said previously, to a mega trend, to the world we live in today, we were able to continue that evolution in a parallel path as, chip manufacturers going from lots of nanometers to a lot less nanometers. So they say, oh yeah, we're going to save you real estate. We're going to be able to do so much more in so little, and you're going to have all this empty data center space. There was an IBM commercial on television many years ago down in the United States, where the 23-year-old kid comes in eating a donut in a data center. So actually, us old data center people cringe. Donuts and water in a data center, and like somebody stole all of his servers and all of the computers. Well, IBM said they were replacing on the mainframe. I'm sorry, not on the mainframe, on an AS400 system. So we didn't need all these old servers. So we're going to have all this extra room. And somebody said, well, wait a minute, we have all this extra room. We have to put something in there. So for every space saving that going down to a 5 or 6 nanometer, production gives us, people are going to say, wait a minute, I can do more. Well, if I'm going to do more, I'm going to need more. I'm going to need more. I need a place to put it. If I need a place to put it, I got to get more electricity. I got to get more climate control and heat removal. I have to be able to monitor more. I need more IP addresses, IPv4 versus IPv6. So our evolution has paralleled what we have seen in the market as we have grown from where years and years ago in the United States, there were data center companies that their business model was not the vertical as Benoît brought out, but that each one of us here in Hamilton or online, wherever we are globally, each one of us would have our own website, and it would be herbvilla.com and sujavit.com and whoever it would be, and each one of us would have our server or two. This was wow. This was like 20 years ago. 20 years ago. We have that today. I'm herbvilla@gmail.com, as well as villa.h@rittal.us. I have my own website. I even have a Google phone, a Pixel 6, to get to my website. So the nature of the business, the applications, the technology, the rapid advancement. Earlier one of the panels talked about Moore's law. You know what? It's old. It's done. I'm not saying it's bad. I'm not saying they were wrong, but it's old news. There's a new Moore's law. That has been where Rittal has gone, is watching what everybody else is doing and making sure that we can support the new applications, support the new compute platform, support the new world that we live in, from the hyperscale to the hyperlocal, as I said before, looking at all the new applications and dealing with all of our new 3-letter acronyms and 5-letter acronyms that have entered our lexicon. VAX, WFH, work from home, right? COVID. We're living in these world of acronyms. We're supporting those. HPC, give me a 3-letter acronym. I'll make it work.
In my past life, when I lived down south, I learned a new 3-letter acronym, TLA. It takes a second sometimes.
Yes, 3-letter acronym.
All right. So my next question, Herb was talking about like kilowatt per square foot in a way. Why don't we talk about a little bit of flops per kilowatt or flops per square foot too? Why not, right? These are metrics, and some of these metrics go into the 3-letter acronyms in the data center world. Some of them don't quite make it, but we still use it. But you have seen this evolution, right? Like how chips evolved from what they used to be to serve a primarily on-prem server pizza box model to and desktop PCs to like they're everywhere now. Can you walk us through this evolution a little bit?
Yeah. So it's interesting, when Herb and I just had a quick discussion about cooling. So now I've used the new, I'm going to change my talk track to thermal management. But, it's interesting because we talk about, giving, higher performance per core with using less TDPs and less wattage. But, human nature kind of starts steering us a different way as much as we're shrinking the data center and increasing the amount of performance and reducing the amount of power per core. But we've now entered the exascale. So when we talk about teraflops, we're introducing Frontier, which is going live soon, and that's our first exascale and be the most powerful supercomputer in the world. And then we have El Capitan that goes live next year, and that's going to be close to 2 teraflops, exaflops. And so again, human nature is that we always want more. And so even though I can shrink a rack in half, give you the same level of performance at half the power and half the amount of real estate. But when you talk to our customers, is like, how do I continue to fill that rack and drive more compute? Because we have the real estate, and how do we continue moving down that path? So it's a bit of an oxymoron when we talk about trying to be sustainable, but things eventually evolve, and we just want more and more. So this becomes more and more relevant. When we talk about heterogeneous computing, our next generation of our Instinct GPUs is what we're starting to use, is what we call our CDNA stack, where we're going to be using GPU offloading onto the processor, and then processor offloading onto the GPU. So everything will be heterogeneously connected and working together. So what that's going to cause in an AI and a machine learning environment is that we're putting a lot of computing into a single chassis. So now we're driving, if we think about crypto in the machine learning, we're putting, 12 GPUs into a single chassis together with, 2 socket processors. You're driving almost 4 kilowatts per chassis with almost, exascale type of computing capability. So the evolution is interesting, and it's become a more relevant term in terms of working with people like Herb. As the question is, what does the data center of the future look like? Do I need to plumb it? Do I need to cool it? Do I need to put nitrogen? It's all this sort of thing. Is how am I going to keep all these systems active? So, but this is the area that that's driving technology, and is also helping us with our future sustainability goals. So. These are all aspects that's kind of intertwining as we increase our capabilities. The human nature factor is kicking in.
Indeed, and 4 kilowatt per chassis. I bet, Roy, you're glad you don't have to worry about something like that in an on-prem data center, right?
Absolutely, I'm happy not to worry about it.
So Roy, natural segue. So to go from that is, I've seen in various roles go from a primarily on-prem to a primarily SaaS-based production model. Could you maybe walk us through a little bit on like how the thought processes that go behind selecting a technology stack change over time? And I would say, like, as a time frame, go from like the mid-'80s to now.
This was an interesting question to reflect on, because I always feel like we're just at the beginning. And I've been in this business now for longer than I'll admit, but a long time. And it always feels like we're at the beginning. And, I love hardware. I love walking into a data center and getting that cool air, and increasingly hot air now in data centers. But it is what it is. There's a lot of factors that brought us here, and the hardware advances are absolutely critical. The reality is software rules the world. It really does rule the world. We've come so far from Pong. Our world is nothing like it was because of software. And it's been a steady progression. I'm glad you mentioned the 80s, because, everyday people started to use computers back in the 80s. And it was largely made possible by a couple of software survivors, if you will. Microsoft and Apple, right, largely made that end user computing happen. And so some of us even started with a Tandy TRS-80 Model 2 computer. Some in the audience may or may not remember that particular product. Through the 90s, the whole thing exploded. We shifted from mainframe-based COBOL time-sharing systems to personal computers, better regarded as business computers. This led, of course, to Y2K or .com era. Internet became a thing, and now we had connectivity. So now we could start to centralize things again, and there we have the cloud solutions that are out there. We once again go and buy time to run software. That's what we're fundamentally doing. So we needed the hardware to run that software. The only reason we needed the hardware was to run software. The only reason we buy hardware is so we can run software. We don't buy it for any other reason, save and except network connectivity, perhaps. And so with software as a service now, as running a business, meeting the needs of the business, which is, as a CIO, that's my job. We no longer need most of the hardware. We don't actually need it, and all the complexity that comes with it. We can just get the software. And in cases where we can't just get the software, we can get the hardware as software. So we can just call up what we need from hardware and build what we need. So it's really fantastic. I love where we are. And as I said at the very beginning, it's only getting started. It's only starting. It's always been only starting since I started this a few years ago, which may or may not involve the 80s.
Indeed. Cool. So I'm going to go a little off script here because I see we are running a little slower than I had anticipated, and we don't have too much time left. So apologies in advance. But like just to have a logical segue, my next question to Benoît, just like we were talking to Roy about, you need hardware for software. I beg to differ. I buy hardware so I can play with them, but that's just me. And that's why I am who I am, I guess. But, and you'll notice that if you go to my lab, there's like, there's so many dead servers everywhere, taken apart, almost a graveyard, people tell me. But, with going to DC as a service, you almost change the paradigm there. Right. So whereas Roy and a lot of CIOs are trying to move away because they don't want that headache of having a data center on premise, you're now giving people who don't want to have the headache of it, but need to have something on premise. So it's kind of a two-pronged question. If you could walk us through, like, how did this need emerge? And then, are there any emerging trends in this that even with this, so you have your core solution, you have your edge solution, is there something in between that you're struggling to meet right now with what you've got?
I think initially it came from a vision from Octave Clavas, our founder, 3 or 4 years ago. Then it was quite difficult to set up, and I think it's turning now a reality in a larger scale in the market. So we're not the only one providing this, but so it might be very European, but actually the key driver at the moment is all what we hear about sovereignty. So who, where, when, and to do what is mass data used. So I will be diplomatic here because big part of the sovereignty is linked with the relationship between Europe and the US, but not only. So there is more and more concern about the data and the way it is used. So I think would be one of the key first drivers, which is people for many reasons, and sometimes for regulation purposes, or for because it's by law and so on, and you have then eventually very, very sovereign players such as ministries and so on. They want to have control on the data. So we are offering with this as a service a very good answer on this data question. Then the second driver, I think, could be around cost. We are hearing more and more that the hidden costs of the cloud are going increasingly high and probably much higher than people were expecting a few years ago. So we are hearing more and more about people that are thinking getting back to their on-premise, what part of what they have transferred to the cloud. This is something which is, we have some buzz about it. So this DC as a service offer, and keep in mind this hyperscaler effect, sharing the hyperscaler effect, is a good compromise between taking the risk and the burden and all this technical legacy of coming back to your own premises and staying in the cloud. We are just in the middle. So it's a good win-win situation for any customer that would consider to try as much as possible to reduce his cost without taking all the burden of managing a cloud, which is getting a more and more sophisticated thing during the years. And then you have some irrational also. This is, I'm a sales, and you have to play with emotion and so on. And you have customers that just want to have their data in their own premises, and they have no rational reason behind that. So the key word there is privatization. What we are selling through this as a service, what we are offering is a privatized service. And this has value for a lot of people. It answers your question?
Yep, absolutely. And I believe in one of the prep meetings, we were discussing a term, data center repatriation in a way. So moving back from the cloud. Okay, so, in the same vein, or this next question is for you. You enable custom builds more than anyone else on this panel, right? So, can you talk to us a little bit about what you're seeing as emerging trends, something, something that is not available off the shelf right now, but like just like Benoît was talking about, this is something you have to do a little bit of patchwork for.
So we do, as you say, we do enable, we build. You tell me what you want to do, tell me where you're putting it, we'll figure out a solution. As far as the trends, there are so many of them out there, whether it's edge, whether it's something as a service, anything as a service. I mean, everything is becoming a service. Do I go public? Do I go private cloud? Do I do on-prem, off-prem? Am I doing hyperscale, exascale, yada scale, whatever scale is up next? I am not concerned with the trends. The only trends that I am concerned with, the trends that I am concerned with are the disruptors. We are not looking at disruptors. So what could those be? One of the trends, 5G, great trend. Oh, this is going to be great. But it is also an opportunity for 5G to be a disruptor. So we have to be careful with that. Certainly our cybersecurity and our physical security. We're aware of them. We read it every day that somebody else got hacked or this virus or that, virus or whatever, machine virus, not human virus, a disruptor. Digital divide. Do we have access to high-speed, reliable, 24/7 internet availability? We don't know that, but that is a utility that we have to have. When my power goes out, I got a problem. If I lose water, I got a problem. If I lose my satellite TV or my cable TV, I got a problem. If I lose my internet, I've lost all of those other things combined. So I'm not so much worried about what new Apple, and I can't predict the future. None of us can. That's my prediction. There's no more predicting the future. If you would have told me that, 5 years ago, I would be driving, I drive a Ford Edge, made down the road in Mississauga. If that thing had more processing horsepower than NASA had to put a man on the moon, I would have said you guys are crazy. But it's true, let alone what we carry in our pockets. I am not concerned with the applications. I'm concerned with the applications as disruptors. That is what we're trying to predict. That is what we have to be aware of. We saw the conversation over lunch using blockchain for South African to improve food production. This is great if they have the digital infrastructure to support that. This is what we're looking at.
Yep. Absolutely. That's the I guess beauty of having a Lego block ecosystem, right? Okay. Marco, how about on the chip side? Any emerging trends that you're looking that require more of a patchwork right now, can't quite meet with existing products?
Yeah, I mean, it's, I talked about the heterogeneous computing. We're all x86 based. In terms of patchworks, migration comes up quite a bit. Can we migrate into their current infrastructure? AMD's brought EPYC back to the market. We're into our 4th generation, but will my EPYC rack work into my current infrastructure? So that comes up quite a bit. So cold migration, everything can coexist. We can expand. So no real issues in terms of expanding that infrastructure, and it also helps evergreen or revitalize your current infrastructure. So why kind of get stuck on something that maybe is aged, but you're not necessarily ready for an entire refresh. But we can attach, fairly easily, even if it's a legacy system. Again, we use x86 architecture, so the patchwork is relatively non-existent in terms of it's a quick driver change. But the heterogeneous computing that I talked about is definitely where the future is moving forward.
Yep, I have a couple of follow-ups, but in the interest of time, I'll save them for after
Yep.
this session. Last question of the session, and then maybe we can take one question from the audience. So I guess no, someone's waving their head at me. Okay, so the last one is for Roy. You talked about moving to the SaaS. You have to have certain things on-prem, but is there anything that in this hybrid kind of an environment that are emerging trends that are like kind of a headache right now, scratching, but you see as becoming something that requires a lot of intervention? Like you probably saw a little bit of that with the pandemic starting when you had to move everything virtual, but anything that's on your radar right now?
Well, I think one of the things that Herb actually spoke about a little bit, and that is around the edge, right? Where is the edge really? I think that's a question that we're kind of working through for the most part. You know, there's lots of legal and contractual reasons that some solutions need to be on premise, and Benoît talked about that a little bit, and that's a fact, right? So, you know, that might decline over in coming years, but it's really hard to say. It's really a tough question. And, you know, I think about what's unmet, and I mentioned about we're only at the beginning. So, you know, are we there yet type perspective? Well, things like building automation, especially with respect to safety and security, you know, we can't have it that an unavailable network connection means that fire suppression systems or don't work, or you can't get a hold of the fire department to come, or whatever the case might be. The immense amounts of data on IoT, we're just getting started on that. 5G will likely accelerate that quite a bit. You know, but how much of it is actually worth keeping? Where do we process that? Do we transmit it over a high-cost network, or do we process it at the edge? You know, and then there's things that have significant latency issues associated with them. In particular, real-time video processing and things like that. You know, so you're trying to deliver a highly personalized experience to your customers. You're going to use a lot of these tools that require local, very close proximity processing, I think, you know, for now anyway. So in general, I think that is what will continue to sit at the edge for some time. You know, the rest of them, I think Herb has it right. We can't really predict it exactly. I think we have so much power in our phones. How much will those be used for edge processing? You know, lots and lots and lots of questions. Again, we're just at the beginning.
Well, thank you so much for putting it so nicely. You know, that's the whole point of having these sessions, is like, we don't really get answers so much. We ask the right questions, and the hope is if we can ask the right questions, the answers will come eventually. But with that, thank you so much to all four of you for being here with us today, and to the audience, thank you so much for tuning in.